So imagine I had a container with some water in it. Can I find the density of any substance? Sure. To find the density of a substance, I would take the entire mass of the substance and divide it by the volume of the substance, because that would give me the mass of a single cube. In our units, we usually use grams and cubic centimeters, and if I divided those two numbers, the denominator would become 1, and I would know the mass of a cubic centimeter. Let's say that this solution wasn't just water. Let's say inside here I had some particles of something else. Let's call it red Kool-Aid. Okay? The more particles there are, the more red Kool-Aid there is. If I wanted to find the mass of the entire substance, I could take some data. Let's say that was a sample of some larger container. Let's say this sample had a volume of, I don't know, 10.0 cubic centimeters or milliliters. They're the same thing. And let's say the mass of the entire sample had a mass of 11.0 grams. Okay? Well, if I asked a question what the mass of 1 cubic centimeter would be, I would take the 11 grams and I would divide it by 10.0 cubic centimeters, because when you divide, you find out the mass of a single cubic centimeter, and let's see, 3 sig figs, that'd be 1.10 grams per cubic centimeter. If I did a different experiment with the same sample, here's my sample. If I did the same experiment, or a different experiment with the same sample, and somehow plucked out all the little red dots, okay? Maybe it's salt water and I've evaporated the water, leaving the dots behind. Maybe it's Kool-Aid. Maybe there's some other way to separate them. If I find the mass of the stuff inside, well, let's see, I need a different name for that. How about mass of the part, instead of this one, which was like the mass of the entire thing? If the mass of the part, which in this case was the red dots, was 2.0 grams, I could find a different ratio. I could say, well, let's see, if I had 10 cubic centimeters, and I assume that every cubic centimeter is the same, every cubic centimeter would have some number of dots in it. Okay, so there's a cubic centimeter with some number of dots. If this is a homogeneous mixture, then every cubic centimeter sample of this should have the same number of dots in it. Well, this 10 cubic centimeter sample I discovered had 2.0 grams. I'll just call them dots for now. Okay? If I divide those, I get 2 divided by 10 is 0.20, with 2 sig figs, grams per cubic centimeter. So in class today, we looked at the difference between these two sets of units. They clearly are talking about different things. This top one tells me how much an entire cube would weigh. Okay, so if I had a cubic centimeter of this mixture and I weighed the entire cubic centimeter, it should weigh 1.10 grams. This bottom one is a totally different picture. If it's the same cubic centimeter, so I'll call this cubic centimeters of the mixture, and I'll call this cubic centimeters of the mixture. If this is the same cubic centimeter of the mixture, but inside the mixture, they both had some dots. Well, what is this ratio telling me? This is telling me that just the dots weigh 0.20 grams. So this is not a good enough unit in the numerator, because 2.0 grams or 0.20 grams, I can't tell that that's the dots rather than the entire cube. So I'm going to have really specific labels, and that's 0.2 grams of dots per cubic centimeter of mixture. So let's look at these two answers. 1.10 grams per cubic centimeter versus 0.20 grams of dots per cubic centimeter of the mixture. Okay, they both look like grams per cubic centimeter, but they're very, very different. This is the entire cubic centimeter, and this is just a part of the cubic centimeter that's contained within. Okay, so this right here we call density, because it's the mass of a cubic centimeter. This is not the mass of a cubic centimeter, it's the mass of something within the cubic centimeter, some component of a mixture. They call that concentration. Concentration is the amount of part per volume of the mixture. That is a different idea than density, which is the entire mass per cubic centimeter. That'll be really important. Also, when we do problems, if we want things to cancel out correctly, we have to make sure that we use correct units. So if I had a problem that said something like this. I have a bigger sample of the same stuff. If I had, I don't know, 2 liters of the same stuff, and I wanted to find out how many dots would be in it, well, I would not use this one because this compares volume to mass of the entire things. I would use this one, this ratio, because it compares a volume to the dots inside. And I could do this. 2 liters, let's see, a cubic centimeter is like a milliliter. So let's do that. 1 liter is 1,000 milliliters. I know a milliliter is the same thing as a cubic centimeter. And now I can say that each cubic centimeter of the mixture, so technically I should have put mixture up here so I can tell them that that's what I'm talking about. Each cubic centimeter of the mixture is going to have 0.20 grams of dots. And that would be the number of dots that I expect in the 2 liters, assuming that it's all homogeneous and mixed evenly. And that's different than asking a question of what would the entire 2 liters weigh. If I wanted the entire 2 liters and I wanted to know how many grams that was, well, that would look almost the same, 2.0 liters of the mixture. Each liter is the same thing as 1,000 milliliters. And each milliliter, once again, is the same thing as a cubic centimeter. But over here, I'd say each cubic centimeter, I don't want to know just the dots. I want to know the entire cubic centimeter, which would be 1.10 grams. That's totally different answer. This answer is the amount the entire 2 liters would weigh. Notice once again, it's about the 2 liters. This is the grams of dots that would have been in the 2 liters.